So if a sub 1 represents the first term in a sequence, and a sub 53 represents the 53rd term of the sequence, in example 3, when we're talking about the sequence 2, 5, 10, 17, 26, when it asks what a sub 3 is, we're looking for the third term. So first, second, third term here. So a sub 3 is 10. A sub 5 then would be the fifth term. So 1, 2, 3, 4, fifth term is 26. In example 4, we want to write a function rule for the arithmetic sequence 5, 8, 11, 14, and then eventually find the 40th term. So to do this, we're going to start off by constructing a table of values. So term numbers. So the first term is 5. So I'm going to put that over here underneath a sub 1. So this is a sub 1 is 5. The second term is 8. So a sub 2, the second term, is 8. The third term is 11. And the fourth term is 14. So we've talked before about constant changes. 5 plus 3, so you can see it's plus 3 each time. I can see that there. So we're going to try and write a function rule. Now, if you think about it, when we did this before, we always were interested in what happened at 0. That was our beginning point before we added anything. So just thinking a little bit backwards, if I had to add 3 to this number to get 5, then it must have been, I'm going to subtract 3 and get 2. So I'm going to think backwards to get this number right here. So 0 would associate with 2. So the pattern then would be here that we started off with the 2, and we added 1, 3 to get 5. Then we had 2, and we added another, we said 2 plus 3, and then we added another 3 to it. I guess this first one's just 2. And then 2 plus 3, and 2 plus 3 plus 3. And then a 2 plus 3 plus 3 plus 3 to get our, is that right? 5, 8, 11, yes. And then to get the next one, we do 2 plus 3 plus 3 plus 3 plus 3 plus 3 to get 14. All right, so when we write our function rule, then we would say that a of n is equal to 2 plus 3n. So notice that 3 is the common difference. So on this problem, D was equal to 3. The common difference was 3. I'll stop there. All right, so using our rule, we're going to now calculate what the 40th term is. That would be very tedious to add 3 that many times. So I'm going to use this rule and calculate what a of 50 is. So that's going to be 2 plus 3, and in this times n is equal to the 50 that's right here. That's the 50th term. So that's going to be 2 plus 150, and I'm going to get 152. So a sub 50 is 152, and a of n is equal to 2 plus 3n is our function rule. So we can use this pattern here and make a general pattern. So we can say that a sub n, so the nth term, is going to be equal to, now in this case 2 represents a sub 0. So a of 0 plus 3 was a common difference, and then n. So I'm going to put n times d. So that would be a formula. A lot of times you'll see this formula written because you have to calculate backwards to get the a sub 0. You'll see a sub 1 is a of n, the nth term, is equal to the first term, a sub 1, plus, and then 1 fewer, so n minus 1 times d. So like if I was looking for the third term, I would do a 5, so 2 plus 3 is 5, and then plus 2 of the differences on that. So either one of the formulas, you'll see this one in books. This one kind of makes sense from what we did. All right, so example 5, we'll repeat the same thing. Write a function rule for this sequence. So we're going to use our thought here that a sub n, a of n, is equal to a of 0. So in this case, kind of thinking backwards, see, right here, what are we doing? We're subtracting 4 each time, right? So our d is equal to negative 4. So what would it have been over here? Kind of think backwards. I'm going to add 4 to it and get 14. So 14 minus 4 would give me the 10. So if I did a sub 0, it would be 14. So it's going to be 14. So the 0 term plus n, the number of the term, times the difference, which is negative 4. So negative 4 times n. Find the 50th term of the sequence, and we would say that that a sub 50 is equal to 14 plus negative 4 times 50. So 14 minus 200, which is going to be a negative 186. So the 50th term, that's what that says, the 50th term is negative 186. I'm going to kind of do this too. If I were to use this formula, it would have been the first term, which is 10 plus n minus 1. I'll put that so we don't know what n minus 1 is, times d. And d was the negative 4, so plus negative 4 times n minus 1. It would be a sub n.